There we go. So let's start with funding. Everybody likes money. Let's talk about why it's broken. So funding in science is broken for a variety of reasons, some of which are included here. It's centralized. To get funding in science, it's a very lengthy process. It's very much elitist, which was what we talked about at SciOS. It's conservative in nature, so it's oftentimes risk-averse in a discipline that is very risk-on. It's susceptible to regulatory, political, and narrative capture, which means that if you're not doing the sexy science of the time, AI is a good example in this instance, you're unlikely to get funded, or your likelihood of getting funded goes down drastically. And these kind of all come together to give rise, in the frame of application science, in something known as the valley of death. There are a number of other phenomenons, but I think this is the one that people are most comfortable or recognize the most. And what the valley of death is essentially in the life cycle of a project, of a scientific project, the timeline, there is a point where you have to transition from theoretical sciences, so that which is done in academia, to more practical sciences, like R&D and therapy development and things that get you closer to actual impact. And that transition often takes a large influx of money to scale up a project in such a way as to make it meaningful. And so this red line is what you would expect to see. A real influx of money to push you over the hurdle. But what you actually see is a dip here. And this is called the valley of death. And oftentimes this is a product of the fact that funding and concentration of funding here tends to restrict itself towards those applications that are either return the highest return on investment or that we can see the foreseeable impact. But there's a lot of science that gets pigeonholed here and doesn't get to move forward. And so this directly stifles the prospect of scientific innovation. The next pillar is ownership. And when I used to give this talk, it was always in the framework of IP. So in science, the major unit of ownership is IP. But this actually extends beyond that. But with the concept of IP, what you have is intellectual property is great for a scientist, allows them to monetize and determine who gains access to their ideologies, to whatever they're developing. But it's also expensive and cumbersome to generate. It's susceptible to institutional capture, which means that, or in practical sense, if you're a scientist doing something at an institution, the institution actually owns the majority of your IP. So if you leave that institution, your IP stays there. You don't take that with you. So scientists don't really get to govern what their ideas lead to. As an asset class, it's very much illiquid. So it's hard to valuate IP. Part of that is because it's not free to market dynamics due to the nature of IP. But the other reason for that also is that IP tends to get lost in institutions. There's such a massive amount of IP and there's so much bureaucracy around IP that you will have shelves, metaphorical shelves of IP that get lost in just the normal proceedings of what happens in an institution. And so it's not openly observable. You can't query it, you can't find out about it, and therefore you can't evaluate it. The other aspect is that there's limited security around IP. There's very few frameworks that IP actually covers when it comes to scientific products or scientific value. A lot of the things that come out of the scientific industry do not fall into the category that can become by IP. They're oftentimes intangible assets, and that is network effects, presentations, software, different aspects of data, and these do not get encapsulated by IP. So we leave a lot off the table as scientists in terms of the value that we can leverage to either help further our research, further someone else's research, improve our quality of life as a scientist through monetization, and the like. And then in addition to that, you have lack of data custody frameworks. So to the point of IP, IP is a legal structure. So there are data frameworks, but what happens to things like genetics? There are no legal frameworks in terms of governing and owning your own genetics. You cannot own your own genetics, even though it is a part of yourself. It is very difficult to own data because there is no legal framework around that data. And so we need to come up with better frameworks of ownership so that we can govern the different types of assets that are coming out of the scientific industry. Publishing is just straight out broken. If you heard any conversations from any talks from Chris, Timothy from A First Approval, and many of the other DeSci projects that are working on publishing, the reason why we have so many is that publishing is a huge issue. The scientific publishing market is projected to be $13 billion by 2032. Practically none of that gets redistributed to the scientists that are actually propagating the science coming out of here, right? This is all monetized by second order and third order party users. So whether that be journals, data brokers, all the like, it's not the scientists themselves that are monetizing. In addition, the scientific publishing industry is predatory and expensive. We have examples of this whereby we see that editors have decided to walk away from, example, Elsevier because of their predatory practices. You have suboptimal peer review systems, which allows low ethical, unverified, unreplicated science to move forward. And we have examples of that with papers that are seminal in their industry. In this instance, Alzheimer's, that have been retracted. And then you have all of these giving rise to things like the replication crisis. It also funnels into the funding issue, but in the case of publishing, replication is a huge issue. The vast majority of scientific papers can't be replicated. And that's not to say that is because scientists are doing bad science, but oftentimes we don't have the units of knowledge or the data units to really convey the information that needs to be conveyed so that you can replicate that science properly, so that you can validate it, value it, and monetize it. So there's a desperate need for us to reorganize, reformulate, and reinvigorate the publishing cycle. Data management is another huge issue. It's a very fundamental one. In the data management cycle, we are still using archaic tooling. We oftentimes talk about bringing science from Web 2 to Web 3. Most of science operates in Web 1 and Web 0. So we're talking about making huge leaps in innovation in an industry that is the pinnacle of innovation, but that still leverages extremely archaic frameworks. I was speaking to somebody who was talking about how in the Netherlands, they still fax your medical records between institutions, right? That's a huge issue. Alongside this archaic tooling are also archaic procedures. A lot of the processing, data management in science is done manually. So Excel sheets, PDFs are all hand done. The data itself is siloed, so the databases don't actually speak to each other. So if I'm looking to work with Carlos or Chris or Tony or anybody in this industry, and my data is located in that database and yours is in that one, we can't really talk to each other, or we have to make these ad hoc adapters to make it composable. We also suffer from something called link rot. And link rot is a product of the lack of persistence of our data. So over the course of a database's lifespan, let's say 20 years, it is estimated that about 80% of the data is lost due to link rot. And that means that you oftentimes, if you give, in the next 10 or 20 years, when you click for papers, you're going to start getting 404 issues, where either the underlying data has been removed and is no longer where this indicator points, or the highway to get there, so the actual road system that gets to that point, has worn down. We need to have better ways for persistence of scientific data. And this is a non-trivial fact. If you think about it, science data is what upholds everything that we do. This conversation that we're having, this live stream that we're having on YouTube, is all dedicated on data banks. And if those data banks are lost, well, what are we actually building on? How do I prove that this is the actual way to do it? In addition to that, the data that we have currently and the way that we convey that data especially is very static. We're living in a world where we're pumping out so much data and things are constantly evolving. It makes no sense that we're leveraging static frameworks to convey this data. We see it in the open source software process. If you go to GitHub, you can see pull requests and push requests showing the updating of a Git repository. If I publish a paper, that paper is static, and the only way for me to update it is to then publish another paper. But I can't do that incrementally. I have to amass a large amount of data and then redo that and go through all the issues that exist in the publishing framework. And so you see, hopefully you see, that all these pain points actually feed into one another and exacerbate each other. And so from a technical perspective, you have that, and what this gives rise to is things like we have no standards. A lot of scientific processing and data protocols have no standards or have a lack of standards, which means that they can't operate with each other because they're operating two different languages. Science needs a standardization to allow for interoperability. We also have a lack of machine readability. In the world of now AIs, but prior to that, precursors to AIs, our data should be readily available in such a way as to allow machines to read them, make it easier to distill out that data, make it simpler for me as a scientist to understand what someone else is doing. We are lacking these things. And then the third pillar, and one that speaks specifically to my heart mostly, is the issues with access. So as I mentioned at the beginning, all of these four main pillars actually tend to culminate in this issue on access. And this manifests in things like paywalls. It's expensive to read scientific journals. For us, it's an annoyance. If you live in a first world or first income country, paying $35 to $50 to read a scientific article, that sucks. I just had to get my badge again because I forgot it at home. It cost me $100. That sucks, but it's not going to break my bank. But if I live in a second income or a third income country and I'm trying to read a paper, that's prohibitive. And so we need better incentive frameworks. There are language barriers, institutional elitism. If you don't go to a high Ivy League college, or if you don't do your academic road trip or your academic trajectory in the United States, North America, or any recognized colleges, universities, and when you come here, your degree doesn't mean anything, even though you might be fully qualified to be able to participate in the scientific record that you're interested in. You have socioeconomic and cultural isms that are prevalent in science. This is not secluded in science. This is everywhere, but trickles into science. You have geographic isolation, which goes back to institutional elitism, but also the fact that different industries do not exist in all places, right? My family's from Barbados, from the Caribbean. We don't have a burgeoning R&D industry, but there's no reason for that not to be the case, right? There's just as many smart people across the world as there are in places where you have these industries. And then finally, you have concentration of funding, which is another issue that basically exacerbates all of this. So a perfect example, and what this looks like if you look at it on a graph, is the scientific paper trail. So this is looking at publications coming out of different regions around the world. And what you'll notice is the United States, Western Europe, and Asia, but mostly the Chinese region of Asia, are the major producers of scientific innovation or scientific publications. And that leads out things like South America, Africa, and the rest of the APAC regions, which are where the bulk of the humanity lives. And so a lot of us, most of the human race, is not able to participate readily in contributing in the scientific record of knowledge. And that's a huge problem. And so when you tally all that up, one of the phenomena that come out of all of this is something called disruptive science, or the lack thereof disruptive science. So there have been many papers that have highlighted the fact that over the course of the last 100 or so years, there has been a precipitous drop-off in innovative science or disruptive science. So science can either happen incrementally, where we make small steps based off of previous building blocks, or you can have these intellectual leaps forward, where you make huge leaps in science. Now, this graph takes into consideration the fact that as you do more science, the easier science gets done, and that leaves harder and harder science. Despite that fact, we still have a precipitous and egregious drop-off in innovation. And so we need to figure this out if we're looking to really revolutionize the world and live in a world where we have solar punk, lunar punk, and all these futuristic perspectives that drive the innovation and bring us to the epitome of what we hope our society is on this planet, and for those of you in the D-Space movement, off this planet. And so how do we fix this? DeSci, and this is what we're here to talk about, is the new kid on the block. But I would be chagrined if I wasn't to talk about the predecessors that led us to where we are now. DeSci is new. Open science and innovation and trying to solve this issue is not. And so the open science movement is our precursor. Now, personally, the issue that I see with the open science movement is that it was too early for its time. It tried to innovate and revolutionize in a framework and a paradigm that did not want it. I think what we have now in Web3, being in this venue, being in this space, we have the opportunity to now create this novel paradigm that can allow open science and now DeSci to achieve the goals that it's set out to do. So what is DeSci? And this is the Ethereum Foundation organization. And if anybody here has a better definition, send it to me, please. DeSci is decentralized science, obviously, which is a movement that aims to build public infrastructure for funding, creating, reviewing, crediting, storing, owning, and disseminating scientific knowledge fairly and equitably using decentralized technology. Now, I've had the debate with many people saying, well, why don't you list this as Web3? And the reason that I personally don't list this as Web3 is that DeSci is not Web3. Web3 is a component of DeSci. DeSci can take tooling and ethos from Web3. But DeSci and Web3 are not synonymous. And I think that's a really important consideration when you go to talk to people that are not in this space. And so this is the DeSci tech stack. Most of you here are already in DeSci, so I don't need to really go over that. DeSci is really, or the tech stack is an amalgamation of distributed ledger technology, which means we move from a centralized point, whether that be in terms of databases or data frameworks or compute frameworks, to a distributed network of stakeholders that each have a say in the game. In collaboration with cryptography, which is actually not a new technology. It's quite old, and Shadi will talk to you about this till the cows come home. But essentially, cryptography is just the ability to exclude somebody from being accessed. So you have a network where you can decide who gets access to what. And this together gives birth to a variety of different tech: blockchain, compute to data, zero-knowledge computation, smart contracts, tokenization. And it's interesting because over the last couple of months, the entirety of the space has been converging around this novel technology of attestations. It's not really new, but it seems like everybody is moving towards that. And that's a really interesting phenomenon. So I'm not going to go into this because we have fine speakers that are much more technical than myself and have been working specifically with these. But see, these are some of the examples of how DeSci are tackling issues in these 5 paradigms, or under these 5 pillars. And this, though outdated at this point, I think is our most up-to-date graph of the DeSci ecosystem. And there are many more people. There are folks in the crowd here that are doing fantastic projects that aren't here, and we hope to have you on here. So if you haven't filled out the DeSci industry analyses report survey yet, please go do so. It's all over Twitter. Just fill it out, and we'll have you up on an equivalent graph. But we have examples of fantastic teams, amazing communities, all tackling things from collaboration via DAOs for a variety of different purposes, funding, community chats, open science, data storage, funding in institutions that are a little bit more TradSci, arts and NFTs, and specifically arts in the form of scientific communication. I think we can pretty up science. I think one of the things that we can take from the Web3 space is that we can have Buffycorns in our publications. We can make science communication fun again, and we can make it so that this side next year, this is completely packed, and over there is less packed because we're cool and we're doing better stuff. And so remember that when you leave from here, our goal is to pack this side next year, or have our own venue because we have that much interest. And so before I finish off, for those of you who don't know, there is a hacker house going on for DeSci, and this is specifically looking at working on interoperability. So there are a variety of tools, as I just showed you in the ecosystem map. We suffer from similar problems in the open science movement in that we're not composing with each other when we should, especially since we're leveraging technology that is made to be composable. And I think we're slowly going there, but that could be done faster. And so that doesn't just mean within the DeSci space, but also within the open science framework. There are a slew of open science tools. Speak to John Starr. He'll tell you about it. He'll show you a fantastic ecosystem graph. There are thousands of tools. We're a small blip in the movement of open science. So it behooves us to integrate with these participants and help propel us all forward. So if you're interested in composing with DeSci and being interoperable in your hacker, come to the Hacker House. We also have a lot of fun time. And so with that being said, this is me. If you have questions, for those of you who are online, please feel free to reach out to me on Twitter, Telegram, by email. Come to DeSci World to learn more about projects. Go to Nerd to learn more about composability. Big shout out to the DeSci Summit for putting this all together. And I think to everyone's point, for those who don't know, the DeSci Summit is a community organization. We did this all or mostly as a community. So a lot can be done when we work together. And that's it. Thank you. Okay. Who? Oh, I don't know. Levy, are you here? There's Levy. Is Lisa here? Lisa Woken? No? All right, Levy, come up. Levy, you're going to have to go around next side. Yeah, go on. So we're going to be having the vision talk, and we'll see. We'll see if I can communicate it. I have some pictures that I'm still building. They're just gonna hand it off. I'm down. Just have a talk. Here you go, bro.
Thank you.
Here's the clicker if you want to walk around like I did.
Awesome, thank you. Awesome, thanks. Okay, test, 1, 2, 3. Can you hear me? Yeah, okay. But louder? What was that? Oh, yeah, that's better. Yeah, hello everyone. My name is Levi. I did not prepare slides. This is just going to be a brief talk giving an overview of data management, compute, and AI in general for blockchains, but for DeSci in particular. So these are mostly like a set of points that if you're a developer building in the space, if you're a researcher who wants to join in the space, or if you're just in general have a general interest in decentralized science, these are the types of things that you want to be keeping in mind whenever you're doing what you're doing. So data ownership and management and location. So the first thing, when you're talking about, when we're trying to do computation over data, the first question is, where is the data located? Right? Is the data located is it private data that's located on a person's phone? Is it private data that's located in a data server somewhere, if we're talking about like a healthcare company, for example, or a social media company, those companies store user data locally on their own servers, right? Alternatively, you can imagine something that you can store on your phone, like your travel data. But even then, for example, Google keeps track of wherever you go. But you can imagine text messages, right? DMs and so on. So the first thing you want to ask when you're looking at data is, where is it located? And if you're doing computations over it, what are the inputs and what are the outputs? And that's going to define how you're going to be designing the protocols that you're going to be building. So one thing that you really, really want to keep in mind, especially because we're working in Web3 and blockchains, is, are you storing the data on-chain or off-chain, right? And so if you're storing the data on-chain, this has a lot of benefits in terms of provenance and in terms of immutability. But if, for example, you're posting personally identifiable information, this is probably something you don't want to post on-chain, right? And so you want to use an off-chain solution like IPFS. And for those of you who don't know, IPFS is a content address file storage system. So in traditional HTTP, when you look up a URL, when you look up something, you look up where it is. You look up its location. In an IPFS, you look up what it is. So you basically have an identifier for a set of information, and that's called a hash. And then you have hash tables that can route requests for where to extract the data that you want to have. And so for something like, let's say, healthcare data, if you want to and keep in mind, IPFS is a public network, although you can have private IPFS networks, or they're being built. You can have your own data stored off-chain, and then if somebody wants to access it, you can give them temporary access and then do something called recryption, which is effectively re-encrypting the data by adding something to it, thereby not giving somebody access to the updated data. And another thing you definitely want to keep in mind when you're talking about data is when you want to do computations over that data is, where is that data located and how much of it is there, right? If you're looking at a 1 terabyte data set, and you want to run some kind of computations over it, if you try to download that 1 terabyte data set, it's going to be expensive and it's going to take a long time, let alone 5 terabytes or 10 terabytes, which are normal data set sizes in scientific computing, right? If you're talking about like satellite data, if you're talking about kind of, let's say, logs of some sensor data or something, we're talking about really truly massive scale data. And so you can't just be moving that around here and there, because the costs are just astronomical, and the time costs are astronomical. And so, it started emerging recently a paradigm called compute over data or compute to data. And what compute over data is, says, the philosophy behind it is, rather than bringing the data to the compute, you bring the compute to the data, right? So you take whatever computation you want done, you put it in, let's say, a Docker image, and then you send that Docker image to where the data is located, and you have the computation run locally, and then you get the result back. And this saves dramatically on costs, and also has really massive benefits in terms of privacy, right? Because if you, let's say, go back to the healthcare example, the healthcare data example, or the social media data example, you don't have to be moving that data, that really sensitive data, over a network, right? And so this, computing over the data where it's located has massive benefits from a privacy perspective. And so we basically also, one side note about the data storage, which is there's, of course, we have blockchains, and we also have distributed ledger technologies, and we also have IPFS and off-chain storage. One kind of intermediate step here are sharded blockchains, right? So there are blockchains that have sharding capabilities that basically allow only a subset of nodes to actually access particular data within that shard. And that is a really interesting use, a really interesting tool if, for example, you want to have immutable data on a blockchain that has consensus over it, but also limit the nodes that actually can access that data, right? So, and then now we're coming to compute, and one of the major questions when we're talking about compute is verifiability, right? And so how do we actually know that computations are done in a verifiable manner? How do we know that that the result you're getting is actually the correct one? And there's three main classes of verifiable computing. The first one is, of course, a really hot topic, which are cryptographic methods, things like zero-knowledge proofs, multi-party computation, and so on and so forth. And those are kind of very popular, and they're being built. Fully homomorphic encryption, that's another one. The second category is our secure enclaves, so trusted execution environments. And those have a lot of benefits. They have some attack vectors, but there's been a lot of work centered around patching up those attack vectors. And the third method, of course, is optimistic verification, right? You just redo the computation from scratch, and you see if you get the same result. And verifiability, of course, is super duper important, because if, for example, you have an application like, let's say, federated learning, where you want to aggregate, let's say, a bunch of let's say the results of running some computation over localized healthcare data, you need to know that that computation was done correctly. So verifiability is a really crucial part of computing, and especially just in distributed computing networks. There's a few other notes about the distributed computing networks we should probably talk about in compute in general, which are basically, there are, of course, incentives in distributed computing networks. This is a really crucial topic for balancing supply and demand and so on. And there's also, especially for DeSci, when we're talking about what kind of computations do we want done, and specifically when we're talking about having a scientific record, how do we make sure that we keep track of all of the inputs and outputs of jobs that are being computed on this network, right? So, for example, if you want to have a project to, let's say, I'm just going to throw out an example, find the cure for cancer, right? You are trying to using computational methods. You're basically running a bunch of computations, or it could be simulations or whatever, and you basically need to know, you have to keep track of the inputs and outputs of all the jobs, who did the jobs, how long did it take, how are they being rewarded. So having provenance over the results and having a record of who contributed what allows you to now reward people for their contributions, right? And now we usually talk about rewarding scientific contributions in the context of scientific publications and so on and so forth, but we can also reward scientific, just scientific computing in general, right? And that's a really important use case, especially for DeSci. So There's another kind of really important topic, which is privacy. And privacy is a major, major problem in Web3 because, of course, we're using blockchains mostly as our mediating data structures. And this is really kind of a naughty problem because on the one hand, we definitely want provenance over people's data. We definitely want to know that the right computations are being done. But people want privacy. People don't want their personally identifiable information done in a kind of open manner where anybody can look at it. So what do you do about this? And so there are cryptographic tools, like I mentioned earlier, zero knowledge proofs, fully homomorphic encryption, and so on and so forth. And so if you're a developer or if you're a researcher trying to do something with, let's say, healthcare data or social media data, it is really, really important to keep in mind where is this data, again, where's the data being located, where's it being stored, what are the inputs and outputs, and how are you maintaining the privacy of the people whose data you're computing over. So there's also, we should probably, I'm probably going to end in 5 minutes, so there's of course, the hottest topic of the year right now is AI. And we should definitely be talking about what can AI do for science in general, what can AI do for DeSci in particular. So language models have a lot of applications in science. It's kind of naturally, it's popping up all the time. We saw, for example, Google's GNOME, which found something, what was it, like 2 million new compounds, something like this. And things like this have been going on for a while. There was a research that came out about balancing plasma with magnets in tokamak nuclear fusion reactors and so on. That was done using reinforcement learning. That's not a large language model. But the point is AI is being used increasingly to make scientific advancements, purely just in terms of actual knowledge. But it can also be used for a lot of other things. So obviously, of course, we can use LLMs for literature review and literature search, right? We can dramatically accelerate how long it takes to actually come to an understanding of a field. By leveraging, semantic embeddings and so on and so forth. So there's also, of course, data extraction and organizing collective scientific contributions, right? So when we're talking about coordinating scientists all around the world, especially who might be speaking different languages, you can basically use large language models to help coordinate scientists to actually help coordinate science, to help communicate results, right? You can imagine having a large language model, in fact, having an agent represent you specifically and then conversing with another researcher specifically, and having those two autonomous agents, go back and forth on results in prior work. And then once all that boring work is out of the way, you can now, when you're actually meeting with that other human being in person, you can start doing far more interesting and advanced things. And so there's a few other topics. Of course, creating knowledge graphs is another very, very big topic. This is a kind of ongoing effort on the parts of this happening a lot, which is, you could imagine just converting scientific documents from PDFs to other formats, and then creating semantic embeddings and knowledge graphs out of it. You could, be if you want to be answering questions like, what's the history of this equation? What tools were made to make advances in this equation? And the next step, of course, is autonomous science, which is asking the LLM, make the next step, make the next advancement in this computation, in this equation, and that's really kind of like the holy grail in a lot of senses. That is kind of really true AGI, and we have to. It's our job, I think, of a lot of people here to make sure that happens in a decentralized manner, where the people who are contributing the data and contributing the knowledge to this network are rewarded, and that we're not really leaving people behind by having all of this knowledge creation centralized in a few entities. And so there's a few miscellaneous topics I also wanted to cover as well, which is distributed signing and encryption. I did touch on this briefly when I talked about multi-party computation, but do you want to make, when you're talking about a scientific community that is advancing towards a particular scientific goal, if it wants to make changes to the scientific object that it's creating, you want to have distributed key management, right? You want to have many different keys, many different parties that each have their own public keys, converge on, agree on a particular state that they want to advance to from the current state, and you want to have agreement between them in that manner. And if they don't agree, well then maybe that data, the scientific product that's being created should be forked. And so there's also kind of a few other kind of miscellaneous topics, which is whether we should have like open or closed models. This is kind of a very, very big topic, especially in AGI safety. Should we be regulating models because they can be too dangerous if they're out there? Or should we be having open source models where anybody can access, anybody can download, and anybody can modify? And this is a really tricky topic with a lot of very important implications for basically our lives going forward, because these large language models are really going to be increasingly affecting every part of our life very, very soon. And the last thing I wanted to talk about was basically orchestration, and whether you have a centralized entity orchestrating or decentralized entity orchestrating computational results, either from LLMs or from other, let's say, scientific computations. It could be like molecular simulations or mapping the Milky Way or whatever it might be. And so there's a big difference between having kind of a centralized entity like a particular scientific institution handling, sending out tasks, handling inputs and outputs of jobs, and coordinating it themselves, or as opposed to having a consensus, a collective consensus over the types of jobs that should be created in this network and distributed accordingly. So, for example, you can imagine if you're doing some kind of like, say, like a collective, like training a genetic algorithm or something like this, and you're doing it in a distributed manner, you could basically have you basically want to have you can have the nodes that are deciding what the next step is. You can have that decided in a distributed, decentralized manner, right? You can have all of the nodes that are participating in it say, okay, this is the next thing that we want to try, or as opposed to having a centralized entity to be choosing that. So those are kind of some basic overviews of like the space in general. Is obviously massive and it's growing dramatically. So if you have any questions, feel free to talk to me after this. I'm also, by the way, a founder of CoopHive, COOPHIVE. Please follow me on Twitter and come talk to me and learn about what I'm working on. And I'm happy to answer any questions about verifiable computing is my expertise, but I know a lot about AI and data storage and decentralized science as well. So yeah, thank you so much.
Hey, Lisa Walken, are you here? No? All right, cool. Okay, so let's transition over to a talk by Chris Hill, and then we'll wrap it up with, I think, a panel with each of the speakers. Well, we'll dive a little bit into funding, ownership in communities, how that relates to compute, and bringing it back all into why we're here today. So just a couple announcements while Chris gets set up. We've been passing around a QR code, an NFC chip, to record basically who's been here today, and the purpose behind that is to collect metrics around the impact of the event, who's attended, and how we can close the loop behind actually evaluating the real-world impact of events like this. Also, please do note there is a social. This is just one of the many events for the week. There's SciOS that's happening in the morning through afternoon, different sessions there. You can check it out at SciOS, that's SCIOS, .DeSci.community. You can check out the schedule there. And we also have our flagship event at the University of Colorado Jake Jabs Event Center on March 1st. Do catch us to hear from folks from SETI and the Go Fair Foundation and lots of really exciting work. And then there will be an open bar event that evening on the 1st. So we've paid for 200 beers, so do please come out and help us drink them. So without further ado, Chris Hill.
Thank you, Shadi. It's a great honor to be here at ETHDenver, which is the birthplace of DeSci. 2 years ago, back in 2022. I'm Chris. I'm one of the co-founders of DeSci Labs. And today I'll take you for a ride in meta-science space. Science is broken. We've all heard it, and it is certainly true. But what is it that is broken exactly? There's a coordination device out there, one that lies upstream of policy, technology, and human progress. It is the protocol by which knowledge is produced and validated. It is that coordination device which is broken. At the center of this coordination device lies a point in space that grants access to the incentive layer of science. A point in space from which all flows, promotions, tenure, grants, career, your future as a researcher. That coordination point is the paper. It is the primary product of scientists. It is the crystallization of new knowledge, a narrative, a story of discovery. It is an ancient piece of social technology with its own recognizable norms. When you see it, you know what it is. It is a way of communicating, a way of exposing ourselves to the scrutiny of our peers and to pay homage to those that came before. It is the peer-reviewed academic manuscript. But what hides behind the paper? A piece of technology called the VOR. VOR stands for version of record. It is an act of speech by publishers. Behind it still lies a protocol, formats, PDFs, and XML, a unique key called the DOI, with bibliographic metadata and metrics. From this object of technologies flows the inputs and the outputs to the incentive layer of science. From the VOR flows the currency of citations and impact factor that come to reward every agent coordinated by that system. Scientists, funders, institutions, R&D heavy businesses all receive rewards from this incentive layer. This coordination device is what orchestrates the system of science. It determines what we publish, papers. The rest doesn't really count. Data, code, software, all of the things that make science verifiable and reproducible are treated as an afterthought, as second-class citizens. It determines when we publish, completed research projects that contain a completed narrative. It determines where we published. We select venues based on a metric, the impact factor, and to a lesser extent today, the appeal of its community. It determines how we publish. We submit Word or LaTeX documents into terrible manuscript submission systems that can take the better part of a day to navigate. The manuscript is then processed by the journal's editor and invited referees. These are the unpaid laborers of this coordination device. We then pay to write on the scientific record, ranging from $1,000 to $10,000 for our work to be open to the public. Or we sell our rights and let publishers erect a paywall before it. And it determines what we certify, an ill-defined process called peer review, where we opine and highlight the flaws of our colleagues' work so that we can render judgment on its suitability for the chosen community. It determines how we evaluate research, citations, impact factor, H-index. It is a complex game indeed, and it coordinates multiple constituencies that each have a stake in the scientific ecosystem. Not just researchers, but funding agencies, policymakers, university libraries, tenure committees, and research institutions. All of them are signaling, in one way or the other, their value to the world based on the outputs of this coordination device. What lies at the center of this coordination device? We call it the VOR singularity. It begins with a protocol on its outer layer, a protocol that enforces the norms of science, but also its technological substrate. Our papers have keys called DOIs, a URL that redirects to the publisher's site. The publisher's site will render an XML object on its web page with a link to download a PDF, or often a paywall gating access to its content. Interfacing with the VOR protocol is a complex, expensive, and time-consuming process. It is extraordinarily hard today for a new journal to connect to it. It can take years to be bestowed the journal impact factor metric, the holy grail, and to be accepted as a VOR validator. And yet, without connection to this protocol, there's no access to the incentive layer. This is what sets apart a blog from a legitimate academic journal. Those that make it through become certified VOR validators, also known as publishers. They run validator farms, known as journals, coordinating vast communities of editors and peer reviewers to carry out their services pro bono. Publishers ensure that the machine runs in good order so that money flows in exchange for their service of gaining access to the incentive layer for meritorious work. At the very center of this device lies the VOR oracles. The VOR oracles are meta-validator. They certify the processors. They certify these validator farms to ensure that they are legitimate in the system. This is the Web of Science and Scopus. While the VOR singularity is slow to change, it is often struck by shocks and must adapt. Every time a shock occurs, the system consolidates further. In the 2000s, 47% of the market was controlled by the top 10 VOR validators. Today, the top 10 validators control 73% of this market. It is an oligopoly that inevitably grows in power after each and every ecological stressors. Today, there's a record high number of scientific societies and small publishers simply throwing the towel and giving in to the leviathans of the VOR singularity. This process is accelerating. In a decade, there will be no sustainable scientific society publisher left. In this business, economies of scale are such that small operations are completely unviable. And while the titans, owing to the economies of scales, data silos, and vertical integration, book record profits. Journals, what are journals? They used to be newsletters for scientific communities. Today, there are certification pipelines to stack our CVs and boost university rankings. Communities used to be everything, no longer. The rise of the pay-to-publish model has left in its wake alienating production lines. It has turned the engine of progress into a volume game. Journal editors worldwide are pressured to accept more and more papers, and publishers charge the price that the market can support, a vicious circle where financial success is measured in production volume. Journals today are becoming alienating, pressured to push out more and more PDFs. Production lines that are often flirting with predatory publishing, caught in a race to the bottom to capture the market. Along with alienating production lines, the rarefication of secure jobs and an ever-increasing pressure to produce more papers grows the dark appeals of cheating, fraud, and turning to paper mills. There's a professional cast of pirates out there that even the all-powerful VOR oracles cannot keep out. Today, the price to purchase authorship in a validator farm endorsed by one of the oracles is twice cheaper than the average pay-to-publish fee. You can buy citation boosters for a few $100. Questionable research practices, p-hacking, and outright fraud are calling entire fields into question. And with the AI revolution, the price of producing fakery is going down by the day. Soon, we will no longer be able to tell. Unless the system changes fundamentally, the paper industrial context is heading into a brick wall. Why is that? Are publishers evil? To the contrary, they care greatly for quality in the scientific record. Unfortunately, just as everyone else, they're bound to the incentives of the system. The truth is that publishers are stuck in a bad metagame where a few overpowered strategies dominate. Consolidate. Vertical and horizontal integrations are hugely profitable strategies thanks to the economies of scales from the sheer cost of efficiently interfacing with the VOR protocol. Capturing data. Keeping scientist captures from A to Z, hoarding data for the training of proprietary system and AIs, creating cascading models where one prestigious journal acts as a light bulb to catch the flies, only to redirect you down a path of second and third tier offerings where the real money happens. Produce volume. Volume, volume, volume. The subscription model in print had the advantage of making volume more expensive to produce. With the digital and pay-to-publish model, all guardrails are down. Underpowered strategies, all the things that are good for science, are bad for their bottom line. expanding the unit of knowledge, integrating code, data, and all other artifacts that make science reproducible as core to a publication. Expanding the scope of curation away from just simply certifying the soundness of a manuscript and the novelty of its results. That is a losing strategy. Peer reviewers already work pro bono, and adding more burden to them would not be viable. Expanding community sovereignty. The fact that peer review today is unpaid is a design choice. It needn't be this way. But naturally, that would chew into the 40% profit margins of these systems to pay peer reviewers and referees and editors. So it can be done. They're stuck in a bad metagame. The VOR Singularity. It is a coordination device that lives upstream of policy, technology, and humanity's future. Despite being extremely profitable, it is a minuscule market considering its importance. Just 20 bips of the social media market. For researchers everywhere, it feels like a black hole that you cannot escape. But let us zoom out for a moment. The VOR Singularity is just one point, one way of coordinating humans and the creation of knowledge. And it is certainly not the best way. We just don't know because we haven't explored. There are so many other possibilities out there in the vastness of meta-science coordination space. This vastness is DeSci. DeSci is a call to explore the vastness of meta-science coordination space. It is a call to all of us, to all of you. The VOR Singularity is not inevitable, and it is not the only way. It befalls us to explore the unknown. Our mission is to carry out this exploration. And who knows what we will find out there, what marvelous worlds await to be uncovered. Contemplate this space for a moment and imagine the possible futures. The antidote to the VOR Singularity is the DeSci plurality. But how can we escape the VOR Singularity? We need to unlock meta-science space travel. So what is that? So what do? We need to expand the space of possible coordination mechanisms to create rich protocols that lets communities find new optimums. The first thing to do is to expand the unit of knowledge, to empower communities with the means to create research objects, not just PDFs and just XML. Research objects are rich, integrated publication that one can build over time, that can contain software, code, data, and much more, stored on an open-state data network that guarantees data integrity and accessibility. Research objects unlock plural modes of publications. We must expand the space of curation, upgrade the nebulous notion of peer review, to break it down, to unbundle it, and enrich it, to expand beyond soundness and novelty. The future of science isn't a paper published in. It is a research object verified by, where communities can issue attestations to verify granular attributes of published research. Open code, reproducibility, commercial potential. There's so much that is ignored by the current model, but that is vital for a sound and rich scientific record. We need to move towards pluralistic validation models. Today, it is one paper, one journal, a one-to-one relationship. This is an artifact of the copyright monetization model. It doesn't need to be this way. The future is the one-to-many relationship, where what we call pluralistic curation. It is not one-to-one, but one-to-many, where different scientific societies can participate in the validation of a singular research object, as crossroads for communities to intersect. Finally, we must expand the space of community sovereignty. The strictures of the VOR have robbed communities of their sovereignty. We must return what has been lost, to let scientific societies decide on their own terms how they publish, what they certify, and the flows of value for their contributors. The unpaid nature of peer review is not a fatality, it is a design choice. We must let communities break free from the validated farms of the VOR Singularity. Ultimately, the victory conditions for DeSci is to change the payoffs of the metagame, to fix the broken strategies. to align profit maxi with meta-science maxis, to make it worthy to carry out quality certification process that extends beyond traditional peer review, to expand the unit of knowledge, the unit of value, and to return community sovereignty. And to change the metagame, we need Web3. Protocols are coordination device that set rules, and by setting rules, we can create new strategy space. We must unbundle the data layer from the application layer, and for this, open state data networks are the next frontiers for the scientific record. From the printing press to the silos of Web 2 to the freedom of Web 3. DeSci is a call to build. It is a call to you, the people of Biddle Hub. Mark my words, by 2025, the DeSci plurality will have become a credible alternative to divorce singularity. Come and help us build the escape vessels that will take us to the uncharted confines of meta-science space. We call these escape vessels ARCs, autonomous research communities. We need ARCs to escape the flood of volume, the black hole of consolidation, and the shackles of exploitation. But there's so much yet to be built, and this is why we need you. The DeSci space has been laying the groundwork for launching these vessels, so get ready for liftoff. Meta-science space await. DeSci communities are joining the launch site, ready to take off with their ARCs on their maintenance flight. Longevist, a longevity research curation community, MoonDAO, a decentralized space research program, Gridcoin, a compute-intensive science provider, the DeSci Foundation, a meta-science community, and your community. Reach out, come to us, and get ready. But make no mistakes. It will be incredibly hard to reach escape velocity from divorce singularity. It will take a lot to engineer viable vessels to travel into meta-science space. But the mission of DeSci is as urgent as it is vital. If we can accelerate science, we can accelerate humanity. So join us. Help us explore the DeSci space. Help us unlock meta-science space travel and reach escape velocity from divorce singularity so that we may usher together the DeSci plurality. Thank you. Thank you to my team. Thank you to the DeSci community as a whole. And thank you to you, ETHDenver, dreamers of a decentralized future. To be continued, come and join us for Vision Talks tomorrow. SciOS is an ongoing DeSci Tech conference this week. And we'll have an incentive design seminar at CU Boulder as well. Mark these dates. Thank you.
Chris, stay on stage. We're going to close out with a panel. We're going to call back Jelani and Levi. Yeah, can we get some more mics too down here? And then Lisa, this is your, if you're here, are you here, Lisa? I don't think she's here. All right, just bear with us while we get set up.
Do you want a wireless for the audience? Or taking any questions?
Yeah,
or
please,
just,
actually.
Okay, so we'll leave them there, and there's two wired mics here by the chairs, so I'll just...
Okay.
Right, yeah, so if you're welcome to pass that one, and there's also two other wires that you can use.
Got it, cool. All right, so what we'll do first is, I feel like we haven't had much chance for questions at events like this and earlier today. So we're going to pass a mic around. If anyone has any questions that they would like to follow up with any of the speakers with, now's your chance to ask about the Divorce singularity. What do we mean by meta-science space? All right, here we go. We've got a question. And please, as you're passing around the QR code, make sure if you haven't scanned it yet to be sure to check in your proof of attendance for the DeSci Quest.
Test.
Do I ask?
Should I ask my question now?
Go ahead, ask your question, yes.
Yeah. So for somebody from the outside looking in, what is the one thing that I can do to get involved or improve DeSci as an individual?
To you, but... Oh, never mind, it works. I mean, contribute, right?
What does contribute mean?
A lot of these frameworks are open. So whether it be joining DeSci Labs and contributing to a node as a scientist, or building out your own node, or investigating nodes and seeing what you're interested in, providing GPU potential to networks so that you can then leverage Co-op Hive to monetize or to be a part of the marketplace, join DeSci World, participate in events like this, learn about the platforms, contribute your knowledge, develop your own engrams. Most of these platforms are open. You can go to their websites. There's usually a contribute tab. Or their communities like DAOs. If you're interested, and I guess the answer to that question depends on what you're interested in doing. Figure out first what you want to contribute, what you think you can contribute. Go and speak with the builders themselves in the community, and then learn about new ways that you can contribute that you never thought of before.
Yes, the space as a whole has an enormous amount of things to build. And it's an incredibly hard challenge. And so we're always on the lookout for open source contributors, for engineers, for game theorists, for protocol architects, for people that are willing to contribute to some of these many repositories and projects. Ultimately, the goal of DeSci is to create an interoperable stack that is multi-layered and that will require an extraordinarily high amount of effort, to be honest, to have a chance to compete against the VOR protocol. So, you know, if you are a developer out there, if you're someone with an interest and a curiosity in contributing, please come and talk to me. Come and talk to anyone around here on this panel, and we'll find ways to really leverage your skills and your talent and to credit you so that you can really make a difference in the space.
Yeah, I'd say follow your heart. Look in this space, look at what bothers you about the scientific system, about the world in general, and dig into it deep. And don't stop, and keep going, even if it sucks, even if it's painful, even if it takes a long time. Keep going, and find people who are like-minded, who want to work with you, and then find where you think you would be most valuable, where your contributions would be most valuable.
So my question is to the panel: how would you make, because we all care, right? We're all nerds and care about all these protocols, but how would you make the greater community care about science and what we're doing here to a level that they start participating without having it to be like too abstract for them to actually engage with it?
I think that's the question, right? Like, how do you, if you can solve that, then we're good. So to Chris's point about the VOR singularity, in the same way, the scientific industry, especially as it relates to the layman, has been so far abstracted that people don't feel a part of the science, despite science permeating all aspects of themselves. So I think the first step is making science understand, people understand in the same way that Web3 does, is that your voice matters, your vote matters, your ability to contribute in a financial system, even though you're not an accredited investor, is important. And so I think we can take similarities from how Web3 has done it from the financial perspective and is still doing it and apply it to science. You need not be an accredited scientist. You can be a nerd, and we're all nerds at heart. Even the popular guys are nerds. They're just really focused on women. But you can create a research collective on how to be a best sports player, how to increase your stats, how to increase your nutrition, how to increase all this kind of stuff. Everybody has questions, and everybody looks for answers. Everybody is essentially a scientist. And I think if we frame it in those ways and just be very welcoming with how we do it, and maybe tone down some of the excessive jargon until it's necessary, then it becomes easy. What are you interested in? Oh yeah, bet? Cool, we can help you build that. Or, if we can't help you build that, you can build it yourself. You can find somebody else to build that. A lot of this is community. ARCs are community. Co-op Hive is a community leveraging assets. DeSci World is community. So it's all community. And I think there are enough communities out there that are hungering for change, whether it be patient advocacy groups, open science communities and collectives, what have you. There are people out there looking for solutions. I think we may not just be tapping into those, and we're going to things like financial industries, institutions, and somebody had asked at SciOS, like, how do you speak to scientists? And I think it was Ronan who mentioned that he goes from the bottom up. We can't go to the institutions. We have to go to the students, ideally the professors, but really the students, and work our way up. We have to become insidious. But I think that the value proposition is so important that it's insidious by nature, right? And I think if we can wrap it around again with the coolness and the vibes and the community support and the Buffy corns and the good parties and weave all those things together, it becomes a no-brainer. We had a party last night and people were talking about science. People who were not scientists. We had Acid Al come and cook meat while still talking about science. We already have the blueprint. We just need to scale it.
I can say. So I think that we have to meet people where they are and find something that touches them personally, because I think that's what will really bring people along. Like we can talk, you know, a lot about kind of in these kind of you know, kind of high level philosophical, you know, ambitions that we have. You know, we want everybody to be involved in how, why, what's in it for them, right? And the reality is that, you know, the world is a rough place, and people don't have a lot of time. And so the things that they're actually going to spend time on are the things that actually affect them. And so we have to communicate, when you're participating in this, what are you affecting in the world? And how does it impact you? How does it impact your friends, your family, your community? And why should you spend time doing this and not something else? And that's a hard question to answer, right? It's a very hard question to answer. Why spend an hour, you know, if you're doing some really decentralized, I don't know, like let's say you're out collecting some soil sample locally from you and, you know, putting it through some like a local, like some solvent or something that was sent to you in the mail to test it out, whatever. Why is that important to you? Why, like, how does that impact you? Maybe you care about the environment. Maybe you care about there being lead or cadmium or mercury or arsenic in your soil or something. You know, you have to really touch people where they are, because I feel like very few people are and there are, to be clear, especially in this community, there are people who will dive deep and deeply contribute for science in general. But if we want to reach a very wide audience, that most of whom have limited time, we have to make it clear why this is a more valuable use of their time and get them more excited to participate in decentralized science than whatever else they might be doing, which could be scrolling Facebook or watching a TV show or whatever else. So we really have to make the case for them, and that really requires finding where it touches them personally and meeting them there.
Yeah, to add to these two excellent answers, we have to build great products. We have to build great products that add value to the scientist's workflow, that showcases their work in an incredibly positive light. And more important than that, we have to build platforms and systems to support communities. Because at the end of the day, it's all about belonging. It's all about belonging to a scientific community. It's all about finding like-minded peers with which you can interact with that will add value to your quest for knowledge. So creating these excellent products that abstract away all the complexities of the technologies that we use in languages in ways that an average internet platform users understands and vibes with, in a way that provides affordances to create belonging with communities. That's absolutely essential, because communities are really at the center of scientific progress. And finding ways to foster a sense of belonging, a sense of admiration, a sense of utility out of partaking in these communities' work is really a fundamental part of creating the future of DeSci and the future of science in general.
I actually think we also have a cheat code. Behind us is a variety of communities that have already been built and understands a lot of the philosophy that we're trying to build. We can vampire attack that, okay? And I say that very loudly. We can vampire attack Web3, because essentially over there are people devising economic frameworks and economic policies that don't really lead anywhere. There's no terminal utility, which is why you have a level of speculation and fluctuation and volatility. We have the opportunity to provide terminal utility to functionality. So not just transacting for transacting sake, but to actually lead to a cause. So tokens can be bound for functionality that is inherent to the system and therefore get locked. So when you're devising tokenomics, it makes it a lot easier when you have token sinks versus token emissions. We can easily fork a lot of the frameworks and tokenomic models that exist over there, bring it here, and make them a lot more viable and functional. And so I think the added part of having community, and we talk about it, is incentives. We need to define very accurate incentives that align with what we're trying to each do in this space and pay people. And it's not that hard. It's really not that hard. We are building a knowledge economy, but you can build economies on top of anything. And it's just leverage what they have. We have terminal utility, integrate it, and let's move forward. That's an easy way to vampire attack other communities and get them on board.
You heard that over there? We're coming.
We're coming for you.
We're gonna suck your blood, hackers.
So, Chris, you started to talk about what my question was regarding abstracting away all the complexity of the technology behind blockchain and cryptography and things like that. But my question for the panel is, how do we talk to scientists and not scare them away from the blockchain stuff? Because for them, it's about, can this help them solve problems? I get that. But as soon as you start talking about blockchain, unless they're part of a very small group of people who have already embraced it, it becomes problematic in their minds often. And so I wonder what you guys think about that.
Yeah, so I mean, it's fundamental to abstract away the complexity. At the end, it's all about creating useful products that add value to your workflow, that make you feel a sense of belonging and community. And you can abstract away a lot of that complexity. And so that's fundamental. For example, reusing a lot of the existing infrastructures, such as ORCID, such as the Archive family of platforms, and creating value for them. We can create value for ORCID by registering achievements, publications, attestations on existing infrastructure. We can create value for preprint platforms by mirroring attestations and indicators of value. We should not build in a vacuum. That's never going to work. We have to build in a way that we interact and integrate with the existing infrastructure such that it becomes a no-brainer. Because at the end of the day, that's what you want as a scientist. You want to get recognition for your work. You want to get your work out there. You want to have peers that look at it, that build on top of it. And for preprint platforms all over the world, they're struggling with trust and markers of reliability. And I think there's a lot we can do there to cross-fertilize between the existing infrastructure and the infrastructure that DeSci is building, while abstracting away a vast majority of the technological complexities, which in my mind, they are inevitable. We have better systems for persistent identifiers. We have better system for archival preservations. All of these things are inevitable.
Unless the scientist is going to go into the back end, don't mention it. Right? I don't go to a website and say, well, I'm running on JavaScript, which is why you should use me. No, I go to Amazon because they can get my shipment to me tomorrow. Talk about your value proposition. I think a lot of us in science, especially in the academic sphere, we don't pitch like entrepreneurs, right? When you pitch to a VC, they don't necessarily care up front how you're going to do it. They want to know what you're going to do and how they're going to make money. Same thing for scientists. I'm going to X times your cost recovery, right? I'm going to make it so that it's X times faster to do whatever. I can make sure that you can guarantee to not be scooped through this metric. It doesn't matter how you do it. Just the fact that you do it, and that's what their outcome is. So I think we pride ourselves, or at least at the beginning, the space prided itself on leveraging this new technology. Whoopee. Now I think we've reached this level of maturity, or hopefully approaching a level of maturity where it's like, okay, we're using blockchain, that's fantastic, but what are we actually yielding in terms of outcomes? And if you just focus on that, like, it's not hard. Just focus on that, and people will come.
It's sort of a combination of those other two answers, which is I would take a two-pronged approach. The first prong is really hammer home how much the current system sucks. don't talk about blockchains. Like because academics hate like academia to a large extent. They're already sick of it, and you really want to kind of like grind that in. Like you really have to emphasize how much it sucks and just constantly remind them and annoy them and remind them of how miserable they are and how miserable their PhD years are and how poor they are because they're being exploited, and really, really remind them of how shitty things are. And then simultaneously, like Chris was saying, lead by example. Make a product that works and solves their problems and abstract away all of the complexity so they don't even know that there are blockchains in the background. They might get interested at some point, but they don't care. They're stressed, they're poor, and they're being pushed to publish like 10 papers a year when in reality they should be publishing 1 paper every 2 years or something like that. And so, yeah, it's really a two-pronged approach, which is hammer home why it sucks and then offer them an alternative path forward.
So I have a question. I'm a tech VC, and the question is like, how do you convince VCs to invest in this space? Because I had a chat with a few colleagues, and it's kind of difficult to convince them, and I think the market is not there. And maybe you need to convince them that there's enough nerds that want to build stuff, and there's a business model behind that. And how do you approach that?
You just call it account abstraction, and then they'll invest in it.
So I think there's multiple answers to that question. Ultimately, what you want to do is a product that people love. I think if you're a VC and you tell me, okay, how am I going to recoup my investment in next years? What's your business model? What's your CAC? What's your marginal profit? All of these things are kind of besides the point, because at the end of the day, if you make something people love, where you have actual scientists coming on these systems and these platforms, creating better research, better knowledge, there's always ways down the road in which you can monetize some of this, right? But I think we have to be very mindful about that. For example, it's a space where hybrid structures that are both for-profit and non-profit are very important, both for creating legitimacy and also for creating separations of concerns. So, yeah, to answer your question, if you're a VC and you're in it, for a short-term token pump, DeSci doesn't need you. If you're in it for, changing humanity and advancing the future and making a bet on a team that has a big dream, that's something that will stay with your firm forever. I mean, it was your company, it was your VC firm that solved the replication crisis. I mean, what more do you want? Going back to your LPs, what do you think they're going to say? They're going to be, oh, well, they solved the replication crisis, but I didn't do 100x. I'm not investing in their next fund. That's not how it's going to go, that conversation. They're going to be, damn, guys, how did you make that bet? That was incredible. So you have to think also about the impact. And I think it's hard because, you're profit maxis, and that makes a lot of sense. But, zoom out a bit and understand just how fundamental for humanity it is to solve some of these core problems in the production of knowledge.
I think that's a very good point. There is definitely a perspective shift that needs to exist in VCs. I had a conversation with a woman who used to work at venture capital and made reference to the fact that there are different forms of VCs that are now starting to crop up that may be more amenable to the kind of things that exist in DeSci. That being said, we talk about DeSci as this monolithic industry, and it's not. In DeFi, you have lending protocols, you have AMMs, you have all these different permutations, and they all require different investment theses. Same thing in DeSci. You have projects that are focused on IP, which is maybe more amenable to traditional ROI VCs. You have projects that are focused on publishing, and that maybe have a longer time horizon or an indirect pathway to return on investment. That maybe doesn't meet that type of thesis, but maybe amenable to other things like foundations or these hybrid VCs. So I think to flip the question a little bit, VCs need to understand what they want and understand maybe the space better so that they can see, okay, this is IP, this is more traditional, I can invest in this directly. Whereas something like a DeSci Labs or any of the other ones that we mentioned previously that are taking a more slower approach but are going to change revolutionarily how science happens, You need to have a different investment thesis. And maybe this is an opportunity for a VC to actually broaden what it's capable of doing, to innovate on itself. We talk a lot about how we need to change the scientific publication, the scientific framework, but within the scientific framework is the financial industry, the publication and IP legislature, and all these kind of things, and it can be a bi-directional innovation conversation that can exist here. There's opportunities within the space and outside the space that can start to crop up by interacting with these different stakeholders.
Those are amazing answers. I'm going to take a totally different perspective, which is there's a lot of money to be made in fixing the problems of science. A lot of money to be made. The classic example, and DeSci Labs is tackling this really amazing manner, is solving the problem of fair data. So findable, accessible, interoperable, reusable data. The lack of this data, there's like on the low end estimate is 10 billion euros a year in lost like value and productivity, simply because we don't have because data, scientific data in particular, but data in general, is not findable, accessible, interoperable, and reusable, right? That is a big problem that affects scientists every single day, but also costs a lot of money. It's a lot of money just totally wasted. And so right there, that's at least 10 billion euros a year that just, you can solve. There's, there's like tons of, like the publish-or-perish crisis is creating bad science. It's creating worthless publications. It's wasting the best years of a lot of the best years of a lot of researchers' lives on just pointless nonsense. It's literally just like you're a glorified copywriter, right? And you're just being like it's just nothing. It's just nothing is being made out of value. I'm not saying, to be clear, there's plenty of important, amazing things that happen in PhDs and so on. But the reality is, we all know, like, there are pressures that waste the time, the money that's invested to begin with in the PhD students, and there's a lot of money wasted in the time that they're spending doing things that aren't productive. And the list just goes on and on and on. I mean, decentralized clinical trials can rapidly advance how drugs are, how quickly drugs are brought to market. There's tons and tons of opportunities. And so I'd say having a clear delineation of where the value proposition that DeSci offers is something that we can bring to VCs and be like, hey, listen, this is the problem we're tackling. This is how we're going to solve it. This is going to be the value that it's going to bring. This is going to be your ROI.
Imagine if you could invest in the internet. Not a company, but the internet. Imagine if you can invest in PDFs. Not Adobe, but PDFs. What DeSci allows us to do is weave in economic incentives into tooling, into protocols. So when you invest in labs, you're investing in an entity, you're investing in the Chris and everybody else who's building out the framework. But when they launch if they launch an economic incentive built into their framework, well, you're investing in the future of what a PDF is. And think about that. If everybody adopts that, of which everybody will adopt that, you're investing in a fundamental unit of the matrix of information. And you couldn't do that in Web 2. You could do that in Web 3. So this is what I mean when I say you need to, VCs or people who are interested in investing have to shift a little bit their mindset and understand what are the capabilities of Web 3, distributed ledger technology, and what is the opportunity, the real economic opportunity that is here. To Levy's point, science is so broken that it's just low-hanging fruit. It's hard, but we're going to get there. It's inevitable. And are you going to be a part of that? Or are you going to look back and be like, damn, I missed the pump. Now I got a FOMO. You don't want to be that person. Not in this space. Not with this caliber of people. Definitely not.
Woo! Any other questions?
I think we got a question over here. Guy in the nerd sweater.
We talk a lot about economic incentives. We're talking about tech VCs, money, tokens, all kinds of cool things. But one of the things that I'm kind of concerned about is the reputation or the sort of the appearance of economic incentives and entrepreneurship combined with being a scientist. And I think a scientist entrepreneur is an interesting new class of person. But how do you feel like that's going to affect the way that science is viewed and the way that scientists view themselves and how comfortable they feel to be a part of that new paradigm where economic incentives, the ability and the requirement to sort of have access to your own funding and raise your own money, that sort of entrepreneurial spirit becoming part of the scientists' arsenal?
Yeah, great question. So it's no mystery that the industry and scientists in general have a strange relationship with money. So on one hand, they just don't make enough. I mean, the state of a PhD student or a postdoc is essentially close to poverty. There's no way for a PI today to increase the salary or the stipend of a PhD student. This is wrong. There should be ways in which your team can find avenues to have additional income. And we need to build this in the system. And when this happens, that can create tremendous welfare. But I agree, it's scary. Scientists have a strange relationship with money. One of the questions that pops up is, okay, well, maybe I win $400 on Research Hub. Do I have to pay overhead to my institution? If it's Columbia, it's 50% or not? There's a lot of questions around this. At the end of the day, though, scientists, despite having a strange relationship with money, they're constantly chasing it through indirect channels, be it tenure, be it grants. All of these vehicles are extraordinarily important. And now, the publishing industry has also a very strange relationship with money. The entire industry is incredibly hush-hush about anything related to how much money they make, how much an acquisition was, how much a service can cost. It's all price upon request because there's great unease about money. It's considered something that's almost impure in a sense, and yet everyone's chasing it. So, yeah, I think we have to be mindful of the social norms in the space. But I also think that, for me, if we could, build products and systems that would increase the stipends of PhD students to a livable wage, we would be just incredibly proud of having accomplished such a feat. And I can guarantee you that if this happens, there will be a tremendous welfare benefits and scientists will line up to have a chance to participate in such systems.
That's a fantastic point. Because there is a lot of cultural taboo that exists in science, and it's not hard-coded. It's just this balance between moral and ethics, and something that exists in the gray line. And you can see it a lot with different jurisdictions. The United States is, I think, much more capitalistic than a lot of other places in the world, and the biomedical space in the United States has different policies or norms than, let's say, other places in Europe. I've recently started working in decentralized biobanking. And it's interesting when you talk about providing incentives to patient populations for donating tissue. Now, both frameworks here and in Europe prohibit you from directly paying somebody to give their tissue. But there's nothing that exists around use-based royalty distributions to a patient. So if a third-party end user like pharma licenses access to tissue or genetics, there's no reason you can't redistribute some of that licensing fees to the patients. In the United States, when we speak to tissue providers, biobanks, clinical sites, they get it. They see it. I was on a call last week with a major biobanking coalition in Europe. That was a huge no-no. Not because it's illegal, because it's such a cultural shift in their mindset that they don't want to participate in it. And so to Chris's point, we do definitely need to toe the line in terms of understanding scientific cultures in a variety of different places, and that was going to feed into how we onboard folks and what kind of opportunities are present. But at the same time, I'm actually not afraid of the idea of entrepreneurial, even mercenary scientists. Because the goal is to drive innovation, and being a mercenary scientist does not necessarily mean that you're a bad person, or that doesn't necessarily mean you're going to do unethical science. It just means that you're motivated by the money, and you're going to apply your skill set to it. And I think that's a fair trade-off within certain bounds, of course. And DeSci works with regulators. We want to work with the FDAs. We want to work with the FDAs and other regulators in the world because we do need to have guidelines and boundaries. That being said, there's no reason we can't have mercenary scientists. And I think that's actually for the betterment of scientific innovation It's for the betterment of developing new, novel tooling, for inspiration, for innovation. And I think it's great.
Yeah, those were really good answers. I'm just gonna say something quick about the kind of an archetype of a particular type of scientist, which is the type of scientist that doesn't do it for the money. Like the classic example is the person who solved the Poincaré conjecture turned down like a $1 million prize, and he said he basically did it for the love of the science, right? And so when we are approaching scientists who really are in it for the love of what they're doing, they have an allergy to money in a lot of cases. It's a very particular type of person I'm talking about, by the way, but these are sometimes often the most brilliant people who drive the field forwards the most. And the question is, how do we help them do what they do? And to Chris's point earlier, it's about abstracting away a lot of the Web3 blockchain stuff in the background, cryptocurrency stuff in the background, and the entrepreneurial stuff in the background. It's really about abstracting that away and clearly demonstrating that this alternative way of producing knowledge and disseminating knowledge is, on a philosophical level, better. Pareto dominates the current system. And if we can convince them of that, then I think their concerns about how they view themselves as entrepreneurs or as mercenaries or whatever, it will fade away. You really need to convince them of that.
Yeah, and to add to this, there's ways to make money palatable to scientists. It's called prizes. It's a very old mechanism that used to be the #1 driver of scientific discoveries until we shifted to grants. But it used to be back in the days, we had prizes. Kingdoms and kings and queens would set up prizes for great innovations, and whoever solved it would get the prize. And we should have more of that mechanisms. We should bring prizes back. And I think there's a lot of people working now on, retroactive public good fundings, which is another way of talking about prizes, and hyper certificates, and all sorts of new ways to create markets for public goods.
Hey, another word for prizes is bounties. You can have bounties, right? We have fantastic. DeSci Labs is sponsoring a bounty or has contributed to a bounty for hackathons. We have so many members in the audience that have contributed to the DeSci Summit by providing money for people to achieve real outcomes. So Chris is absolutely right. You can have prizes, you can have bounties, and people who take on bounties are mercenary scientists. We already have these frameworks. It's time to reintroduce them to scientists and understand, to Levy's point, be amenable to and be cognizant of what their internal culture is. But it's very simple.
Hey guys, I got a question about pharma and biotech. So on a 10-year time horizon, how could pharma and biotech benefit from DeSci? Is there any mechanism that you could see, any value that we could create that they could benefit from?
Yeah, so we have a other prominent DeSci project called Molecule that has been working on creating liquid vehicles for IPs called IPNFTs as a way to create funding for scientific research projects and to carry on the evaluation of commercialization potential. And so for biotech VCs, you could think about these vehicles as a way to create earlier opportunities for liquidity that can then be reinvested in the process of carrying on clinical trials and feasibility studies. So there's a vast space of potential for essentially creating financial instruments that can bridge the innovation gap, right? That death trap that's between fundamental research and applied innovation, which is the valley of death, and finding ways to essentially create funding opportunities, funding vehicles is an incredibly worthy task because bridging that gap could absolutely accelerate humanity's future. And for biotech companies, it's something that's very interesting, I think. There's lots of BioDAOs as well that are pooling resource, pooling data, pooling the skills of their contributors towards a greater understanding of some fundamental diseases. There's also data DAOs in which patient populations with rare disease, they band together to create incredibly valuable databases that can then have redistributional properties back to the communities that have provided the data. So this is a way for essentially incentivizing data aggregation, uniting communities, creating vehicles that create welfare benefits back to these communities in an incentive-aligned way, which we just don't have today. So yeah, there's a lot of potential within the biospace, which is incredibly capital intensive, incredibly risky. It's a very, very difficult space to operate in. It's deep tech, it's deep biotech. And I think in the DeSci space, there's going to be a lot more emergent models about how we can bridge and bring liquidity in order to sponsor or essentially avoid or mitigate the effects of the valley of death.
So I personally classified this definition as fantastic in the frame of what kind of novel innovation DeSci can bring to biotech and pharma. But in addition to that, I think there's also operational efficiency, which is very prominent and they can understand today. Pharma is a huge market. It doesn't quite operate in Web 0, but it operates in Web 1. And a lot of the processes and operations that exist in pharma are extremely inefficient and take time. And time is money. And so if you can streamline operations, you can directly increase profits, not by changing any other asset, but just allowing things to move faster. In addition, in the biotech space, if you look at things like crowdfunded cures, and those entities that are looking to recycle therapies, find second-order applications of therapies, essentially allowing you to increase the portfolio of return on investment of a particular asset. Web3, or ability to find new data around a particular topic, find new IP frameworks around those topics, being able to converge and collaborate and consolidate different IPs, that's another way. And I think a third way, and one of the ones that are most prominent, and I think we need to start marketing more, is cost recovery. The value proposition, I believe, and I've spoken to a few pharma investors and pharma VCs, that they have in things like VitaDAO and these DAO communities, is de-risking. DeSci, grassroots DeSci as I like to call it, is a lot more risk on. And so pharma can take an investment, put a $1 million, $2 million investment in Vita, and allow that community to de-risk assets, or to do at least the due diligence to determine what assets are more viable than not. And then they can come in and they can broker deals with the DAOs or the collectives and whatever, ideally paying those participants for their contributions, and then get those IPs. And so they truncate. It still might take 10 years, but they have to invest a lot less money. There's a lot less risk. And so I think there are a few verticals that, especially in the biotech space, we can market the value proposition of DeSci, both grassroots DeSci, as I like to call us, and those that are more enterprise-facing DeSci, like that attack directly the operations side, and to show the value of that what we have here.
I'll just add one point to that within my space. There's this prominent example of this company Amgen that tried, engage in replicating 50 top scientific papers published in the top journals, immunology, Nature, and so on and so forth for early cancer treatment markers, if I remember correctly. They had a replication failure rate of 90%. Hundreds of millions of dollars wasted on the burner because the original research was just not robust. Now, as a biotech company, before I engage into listening or reading these academic papers and drawing, looking for new therapies based on these results, I'm actually very interested to know if these results can be reproduced. Is the data available? Is the code available? Can I trust these results? The answer today is no, you really can't. And imagine if you had a peer review process, quote unquote, where you could have a much richer validation process, where you could have the assurance that the results are reproducible, that the data is available, that you can build on it in safety. Imagine how much millions of dollars biotech as a whole could save if only science was more robust and only if validation process was more holistic and actually validated the things that make science verifiable. So for the biotech industry, it would be a no-brainer to engage in a service economy that actually attests to the quality of published research beyond the traditional process of peer review.
And so that makes me think of another really interesting point, right? So we talk about the reusability of actual assets like drug discovery, right? But when we're thinking about things like fair data principles and the R being reusable, DeSci Nodes or DeSci Labs and the DeSci Nodes platform essentially creates you a place where you can upload negative data. So your failures, right? And there's a lot of valuable information that exists in failures. Out of all of the profiles or the IP that a pharma is trying to develop, the vast majority of them fail. Now that's a failure for the pharma itself, but that data around that failure may be extremely valuable to another pharma participant or another institutional participant. And so the ability of pharma to recycle their negative data or leverage their negative data and create new marketplaces which can then be sold off so that it becomes a new asset class for them, or they can either profit from that or have cost recovery to then funnel more money or to divert these proceeds, profits, revenue, into other initiatives. I think we have the opportunity here to create novel asset classes, define asset classes that are permissioned, can be permissioned, because we are talking about a highly competitive corporate industry. They don't want to just leave it out to everybody. But they can come to a node, probably split one up internally, kind of like a hyperledger of information, and then farm it out. Say, hey, listen, this didn't come to term, but this data may be extremely valuable to you, Amgen or Vertex or Merck or whomever. Are you willing to buy it? Or do you want to come in together? Do you want to have a licensing agreement? All these novel frameworks are possible now with the tech that are being developed by all these people here. Now, I think the innovation is just, what we've scratched is just barely the surface. A lot of cool things that are going to come out in the next 5, 6, 7 years.
I don't have much to add, only like a few minor points, which is like lowering the barrier to entry for research. That's a really big one. More directly connecting the supply and the demand. We have the researchers and scientists who have the supply, who have the know-how and are able to carry out experiments. And then the demand is coming from regular people who say, hey, I have this problem. I would be willing to pay a bit of money or contribute a bit of money to a scientific project that may or may not result in IP or return to me directly, but at least I'm connected to the science that's actually being done instead of paying taxes to the government, which then gives the NIH, what is it, $50 billion a year is their budget, I think, something like that. A $50 billion a year budget with a massive lack of a very poor replication rate, as Chris mentioned. And then having no control over this absolutely monolith, like this Bohr singularity, like just like totally out of control, and this is, by the way, this is why a lot of people don't trust science. We have a real problem right now in this country around people not trusting science, right? And not trusting scientists. And they're not wrong to not trust scientists given how many scandals are constantly happening. Why are those scandals happening? Because our incentive systems are broken. It encourages people to lie and cheat and steal. And not to do actual proper science. Not everyone, to be clear, obviously. The majority are honest. But this is why people are getting sick and tired of this system. And so a lot of it has to do with connecting people directly with the things that impact them. And that's how you get people to care. And that's a source of revenue. That's improving how the scientific processes go. These two killed it, explaining that. There's so much value to be created. It's low-hanging fruit, really. I mean, we're all early here. We're all really, really early here. So this is a good time to be here.
Another prominent example, the amyloid hypothesis as the causative agent of Alzheimer's disease. Billions of dollars burned over a fraudulent paper. If we had open data, open code, and we could have verified the thing, we could have passed it to have a more holistic validation process, we might have avoided billions of dollars of wasted resources, and we might have even saved lives of people that are affected today tragically by this terrible disease. Think about it, billions of dollars to produce 1,000 or 2,000 PDFs. I mean, this is incredibly inefficient. So we need better ways to attest to the quality of published research.
From billions to billion to millions to million. I think that's a good KPI that we should look for from the biomedical space in DeSci. Can we bring down this cost of doing any kind of innovation? I think we can. Go ahead, Shadi.
Yeah, I just wanted to give a little bit of space towards the end for one final sign-off for the audience. I think it's good to, maybe we could go real quick, one, existential threats to science or DeSci, one massive opportunity that you think is worth taking time or effort into, and then something perhaps that you're looking forward to either at this event or in the next couple months.
I got 50 seconds. Existential threats. Well, we need the talent to flow in DeSci. We need a couple of things, right? You need talented people to flow in. We need capital to flow into the space. That's how we're going to be building these escape vessels. And then we need to build great products that people love to use. And so that is an incredibly difficult challenge, but we will get there. I'm confident in that space. And yeah.
Existential threat, narrative co-opting. I think as we grow and as people become more aware of what we're happening, and because a lot of these tools are open source, there are going to be bad actors or less aligned actors that are going to try to make money grabs. And I think we need to be as integral, as stand-up, as credible as possible to counteract that. And I see everybody here in doing so. So my vision is, personally, we're going to have a vision talk tomorrow or the day after, is a space where DeSci and all the barriers, or DeSci allows for all the barriers to science to come down much, much lower, whereby you can be a chemist in the Amazon forest or an engineer teaching a child about quantum physics in the tundra, Siberian tundra, and you are just as accredited or you're just as meritocratic in doing this as anybody else.
So existential threats. I'm borrowing this directly from Jonathan Kung, who I did see in the audience earlier, which is us all getting bought out in like a year or two for like 20 million bucks, and just the same institutions that caused this problem in the first place, just perpetuating the problem. That can happen. And how to prevent it? Honestly, I don't know. I don't have a good answer to that question. So that's something, yeah, maybe we can talk about during the vision talks. It's a really serious problem.
Thank you to BiddleHub. Thank you to the DeSci Summit, Shadi, John, everybody else who has provided funding. This is one of many talks. Join the rest of our talks, our events. Come to the houses. Go to all the people. Speak, learn, participate, and let's have a good time.
Thank you for an hour
Thank you,
panel.
everyone.
You guys are awesome.